Hey guys, welcome back to the channel. And in today's video, we are going to be looking at a very interesting topic. We are going to learn how to automate our scripts using Github Actions, and GitHub. I have a document which showcases the objectives of the video, the use case, and we'll talk about a couple of extra things as we go along in the video. So the use case is that we work for an edtech and we collect survey questions about a particular course to measure how our students rate the course on the content, the teaching style, and the overall satisfaction. We create some metrics based on these survey questions, and we store these results somewhere. For this example, we studied results on Google Sheet. Now the task is we want to automate this process so we do not have to keep rerunning the scripts over and over again. In the case of this tutorial, the analyst runs the scripts every morning of the new week, and instead of them auditing their systems and running the scripts, they just let they just automate the whole script so that it runs every morning without them having to interact with the script. So benefit of automation saves you time and effort. You don't always have to go back to click on buttons and set up environments. You just have a virtual computer which loads in your environment, loads in whatever you need to run the scripts, runs the scripts, and processes the results, stores the results somewhere which you can use later on. So we're going to head over to R, but before we go to R, let's take a look at the survey. So this is a simple Google Forms. By the way, everything here is simulated. So it's just a quick just for this video. So we asked the first question: who taught the course? We have a couple of teachers. Students are meant to rate. So I pick Aisha. The course content was clear and easy to understand. Let's how you agree with the following statements. So I'm just going to give them some random ratings. Let's do the same thing for the next. So this first block talks about how students saw what's the course, the contents metrics. Let's just say context metrics. We want to get an overall score, which will be like the average of these three questions. We rate them from 1 down to 5, then get the average of these three. That's how we calculate the metrics for content. Then we go over to the instructor. So we ask questions on how they interacted with the instructor. Was the instructor explaining the concepts clearly and effectively? Were they responsive to students' questions? Yes, they were. Did it create a positive or inclusive learning environment? Say it did. Then the overall satisfaction, we do the same thing, click on some random values and we submit. So it's done. Now we have an R script that cleans and analyzes the student responses. So we have this block of data, stores the time. A lot of this are simulated data, by the way. So we have results popping up here. All these fields were created by me. So as you can see, the fields here, they don't have really nice column names. So it's pretty cool to just have have that processed in here, where we have proper dictionary where we can load in our R script, and I will show you how this comes into play. Our metric, this is what we are trying to measure. With timestamp in this case is the time we updated the results. So for this video, the result hasn't changed because the inputs didn't change. So you can see we have the same results over and over again. But I'm going to show you how all this were done, and we'll learn along the way. So let's go over to RStudio and work on automation. Okay, now we're in RStudio. Before we get started, I already have the scripts used to run this mini project. So we are going to take a look at the scripts component by component and explain the key parts of this project. Before we get started, we should know that this project is into two, basically. The first part is running the script that does all the metrics, that gets the data, processes the data, calculates the metrics, and exports the data somewhere. That's the first part. The second part is setting up the job that takes that script and runs that script without us doing anything. That's the automation part. So that's where we're going to spend more time. But before we do that, let's take a look at how the script works. So first, we need a couple of libraries. We are going to be pulling in Google Sheets, dplyr, and some tidyverse, libraries, janitor, and Emily. So Emily is for sending emails. Janitor is for cleaning column names. I didn't set up tidyverse. Instead of I used this instead because when we want to automate this script, we need to install the libraries every single time. So using tidyverse might take a longer time to set up an automation job for. And since I'm not using ggplot or any other other advanced or other tidyverse libraries, I'm only using this for. So it's better to use this than use tidyverse. Now, when you are working with Google Sheets libraries, in real sense, you would need to authenticate access. So you most likely would not want to let your data be for the whole public. It's most likely going to be private. So you need to be able to set it up in a way that you can bypass that authentication process, because when you run your job automatically in an automation mode, there is no clicking. So for example, I'm going to show you what I mean. When I don't run these sections, I try to pull in the data. You see, it sends me to some kind of authentication step where I tell it use my email address, and it pulls that data for me. In the case of automation, there is no time for you to set up the email address. There's no time to type to. You need to be able to get that data without this step. So for you to do that, there's something you need to look up called service accounts. I can make a more detailed video later on how to set that up. But for the case of this video, we already have that set up, and we have a service, an encrypted service account key, which we can use and can access Google Sheets without this step. We bypass this step. So I'm going to restart my session and try it again. So let's do that. Set my working directory. I'm going to load up all the libraries again, and I'm going to so what it does, picks up my secret key and authenticates it. So when I try to run load data, as you can see, I didn't have to go through the step of typing which user I am. So when we are running our code online on the virtual machine, it works fine. So I pull up two sheets. I pull up the first sheet, which has the data I'm working with, and the second sheet, which has the code. So I would want the column names to be this. So I do a basic transformation. So what I want to do is to reprocess this data. I want to convert my Likert scale values into numerical values, which I can get averages for, and calculate some metrics. I have a function that gets KPIs what I want. So basically, it just gets the average. Yeah. So I want to get the average of content. What I do is to pass in the data and pass in the content columns, and it gives me the average, the combined average for this, and this. So that's what we defined our metric to be. Now let's get some metrics. So what I want to do is to get an overall metric. I want to get metric for the content. I want to get the metrics for the instructors overall and per instructor. So I can start with, I'm starting with instructor. Pick up the instructor columns. I calculate instruct KPI. Okay, I need to load in the function. I calculate the KPIs for each instructor. As we can see, Binta has the highest, followed by Aisha, then Izzy. Then I calculate the overall KPIs and the rest. So at the end of the day, I have a timestamp. So this timestamp is just telling me the time this code ran. So I ran this code on the 22nd of February 2024 by 23:44 p.m. That's close to midnight. So yeah, that's that. Then at the end of the day, what I want to do is to take this table that I just created, and I want to append it to the sheet that I showed you earlier. I want to append this table to the sheet. So we have a new metric that we can measure at a different time signature. So what I did, I took this row and I've appended it to the Google Sheets table that we had earlier. And next, I want to send an email to myself and a couple other downstream users. So for this case, I'm using my email address, set up an SMTP get. I just send a simple email. So the email content is just basic. This is the link. So I just send the link of my Google Sheets. Send it to this email address. So if I had more email addresses, I would just update this and add new email addresses. Then I use the functions and I send it. So at the end of the day, tries to send yep, and it goes all done. And yeah, that's basically my entire script. That's what I want to do. This is all I want to do. On a normal day, what I might do is to every morning I just come up to my script and I just click on run, and that's fine. I mean, no issue. It's going to run. But if you think about it in the bigger picture, if you had a lot of scripts to do, a lot of tasks to keep repeating, it doesn't make much sense to do it every time if you can automate the script. So I am going to talk about how to automate this and take your hands off the steering wheel and let the robots do the job for you. Before we go into that, let's take a look at the Google Sheets and take a look at how the email went. Then we'll come back to the automation aspect. So we're back to the sheet. Let's head over to the metrics tab. As you can see, we have a new row added on the 26th of February. So the time is 1 hour off. I think time on my house studio settings isn't using West African time, so that's what settings off a little bit. But as you can see, the metrics is updated. So we just have new rows, and users of this table can see a progress. For example, if this was the start of when the course started, this is the initial point. Users can see how the overall KPI has been progressing. So for this example, it hasn't changed so far. It's still at the same. So 3.84 is pretty good for a course, but you'd probably want it to increase. So yeah, but for this project, this is all what we want to do. I'm gonna show an example on how the email will look like. It should pop up on the screen in time from now. Then yeah, let's go back to our studio and see how we can automate this job. If you are thinking that to automate this job would need a complex amount of code, I'm sorry to disappoint you. We just need a simple YAML file. What does this YAML file do? It's just a set of instructions. So let's imagine this. You have a blank computer. And you want to run an R job, an R script or whatever. What do? The first step, you have to install, an OS. It's a blank computer. There is no OS, there is no Mac, there's no Windows, there's no Ubuntu, there's nothing. You have to install an OS. Now, let's say we install Windows. We install Windows OS. Okay, now we have a blank Windows computer. What's the next step we do? We try to install RStudio or install R. Okay, we install R. Okay, now we have R in a Windows computer. What's the next step we do? We then try to install, we try to run the scripts. We try to install the packages that we need. We run the scripts. Then we end the job. Kill the session. We'll uninstall R. We uninstall the Windows OS, and we kill the session. And that's how it works. That's basically how we're doing it here. So now, on this YAML file, the first thing we have here is the on. So on key is basically telling it, how do you want this job to run? So on schedule, we are using a cron tab, a cron syntax. So there's really no need to learn exactly how to write cron syntax from your head. To be honest, you could just use ChatGPT or Stack Overflow or something. There are millions of cron syntax tool out there you can use to generate cron syntax. In the case of ours, I am running a job to run every 9 a.m. on a Monday, as the task indicated. There are other ways to trigger this. There are other ways to trigger this automation job. I commented them out here, as you can see. And on a push request. So if there's a push request, if you're working on GitHub, say you are working on a package and you have some tests and you want to make sure that before you merge or before anything happens, the test runs first and it all runs successfully. There's no error, there's no breakage in the code. You want to ensure that the codes are all correct. You can set up an automated job to do that. So whenever someone sends a push request or there's a pull request, this job is triggered. But in case of our projects, we don't really need to run this job on push or pull request. So it's just out there. Now, the next header on the on section is the workflow dispatch. So you might want to put this if you want to manually trigger this job from GitHub desktop. Then you'd want to put this. It's always very helpful to put this when you are testing on your code. Just makes life a bit easier for you. Now, the next step is name. So the name of your job. Always good to have a very descriptive name. So as you can see here, we say update edtech metrics. It can be anything. Now we get to the meat of this of the automation tasks, the jobs. So it's like I said, it's a step-by-step action. So imagine everything is, you have a blank laptop, you have a blank space, you have a blank, laptop. It does not have an OS. So we say it's going to run. So all these keys, all these things are these are the keywords you need. So it runs on what OS? So I'm using the Ubuntu latest. You can use Windows, you can use a particular version of Ubuntu. It depends on the use case. But for me, I'm using Ubuntu latest for this video. For some environment variables. So as you can see, you saw in the scripts where we ran a couple of variables are not out there. I don't have them in public because they are like passwords and they are meant to be kept secret. So you'd want to keep them as environmental variables. So environment variables, you call them in your session, but you don't use them per se. It is not out there for everyone to see. So if you want to have this kind of variables in your job, you need to set them in the env environment. So whatever keyword you use to save them, Google Drive key, it's what you have to use in your scripts. So as you can see here, we have Gmail username, Gmail password, Gmail username, Gmail password. It have to be the same thing. Then I'm going to show you how to set secrets in GitHub. I'll put a link in the description of this video. Now, once all your secrets, all your environment variables are declared, you then start with the steps. So the steps are from start to finish, from setting up your session to running your scripts. Now, there are a couple of actions we can use, rlib actions we can use. You don't need to install or write code to install R, because rlib already has a couple of helper things that we can use. So whenever you are in doubt of if it's already available, what you can do is to head over to rlib, R actions, and in this GitHub page you can take a look at a couple of actions. You don't need to repeat those tags anymore because they're already available. So stores GitHub Actions for our project. So set up R, would definitely need to set up R. We need to install packages. So we are using this too for our case. For your case, if you're working with Renv, you can install from Renv. If you you want to check your R package, you can use this. It depends on your use case. But for this project, we are going to use set up R and install packages declared in the description file. So let's head over back to our studio and set that up. So as you can see, I just used these actions, quite easy actions. There was no point of me, writing R code to, install.package, whatever package I'm using. But something I forgot to mention is that this file, this YAML file, has to live in the .github folder under workflows. It has to be there, and whenever this job runs, it starts from here as base. So as you can see, I want to source my update script. So I'm starting from here as base, down to R, and down to update script. So for example, if I had multiple layers of folders, I need to make sure I'm starting from this root directory and finding my way down to wherever the script I'm looking for is. Okay. So after setting up my R environment and loading up my libraries that were declared in description, make sure to have a version. It throws some errors when this is not a package, this is just a script, but make sure to have a version. Whenever you don't have a version, it throws up an error in Github Actions when you run it. So these are a couple of packages I want to use. As you can see in my scripts, I have them up here. So I just added them to imports. Then in Github Actions, it comes here and installs the packages that are under imports. Yeah, it's that simple. So once it's done installing, we just source this script. So it comes here, runs my libraries, authenticates Google Drive and Google Sheets, loads in the raw data, cleans the data, gets the KPI, appends the sheet, and sends an email. So it's that simple. Once that is done, the job is done, and that's it. It closes up and it runs whenever the next time it's scheduled to run. So when all this is done, you push up your file to GitHub. Going to head over to GitHub now, so I can show you how it works. How it works in action. Okay, let's go over to GitHub now. Okay, we are in GitHub where everything is meant to run. We have pushed all the files to GitHub, and once you push your files to GitHub, you automatically should see an action. Once you click on the Actions tab, you automatically should see your workflow name here. As you can see, I've run them a couple of times. Sometimes it failed. If it fails, you see a red circle here. If it passes, you see a green circle here. So you can zoom into it and take a look at why it failed and try to fix it in your script. Then you push again and you try, and yeah, at the end of the day, you should get a green. So when you click on the workflow you want to run, remember when we set up a workflow dispatch earlier, so we can trigger it manually. So I can trigger it. So good thing to note here, if you're working on a branch, say you want to add functionality to your automation scripts, but you're working for in a big setting, you would not want to push your commits straight to the main branch. So you'll have to create a pull request, and you work on that pull request. So if you want to test that, you'd have to run the workflow file on a particular branch. But since we don't have that, we just run the workflow file on the main. You can click on run workflow and give it a minute. You can see it's starting to run. So it's going to take a while. Let's click on it. It's going to take a while to run. As you can see, it's in progress. We click on it to expand the box to see set up the job, check out, set up R, install. Yeah, as you can see, it's a lot of stuff. So I'm going to pause the video, and when it's done, we'll take a look at the final results and look at the metrics tab and see if we had any updated records. So to remember, we only have 5 records, and if this runs perfectly, this runs fine, we should have a 7th row down here. Okay, I'll see you soon. Okay, so as you can see, we have a new record. It was sent in 2309, which is later than the previous one. It's the same metric because the data didn't change, but as you can see, our automation job ran successfully. So you can see the green mark, all done. Yeah, the email you can see on the screen too, it was sent. Yeah, that is basically how it is that simple to create automation jobs in R. The components you need are the script. Basically, that's where the bulk of the work lies in the script. Second part is you need to ensure that the entire process works without authentication. If you need to authenticate something, you make sure that it's done in a non-interactive mode. So in the case of our Google Sheets, we had to create a service account, which were able to generate a key, which we were able to, authenticate things in a non-interactive mode. So automating our scripts is very, very important. It's a very powerful skill set to have in your arsenal. It makes your life a lot easier, and there are so many applications to doing it. It can be combined. It can be combined with a larger, this is a simple application. You can automate things, automate your models, automate your data pipelines, and a couple of other things. So the possibilities are limitless. It's just up to your use case and your imagination. So yeah, that's all I had to show you guys in this video, and I hope you found it useful. If you have any questions and comments or any issues you've had along during automation, feel free to reach out to me in the comment sections, or send me a mail or LinkedIn. I'm always happy to help. Okay, I will see you guys in another video, and stay safe.